Thank you very much for coming. My name is Warski. I work for SoftwareMill. SoftwareMill is a custom software development company, also a fully remote company. If you are interested a bit in that, please visit our website. So I'd like to talk today about annotations. Annotations are definitely a very successful Java feature, so they are very widely used. And they have definitely transformed the way we do programming in Java in a positive way. But maybe in some cases we have gone a bit too far, and maybe it's a good idea to actually reconsider some of the places where annotations are being used, and maybe there are some patterns which might be better instead of using that much annotations. But before starting that, it's actually my fourth time I have the occasion to speak at GeeCON, and I was looking back when was my first talk, and I found today that it was in 2010, despite the date in the bottom. I have no idea why it says 29. So it was in 2010, and I was also talking about annotations. So I don't know, maybe it's time to stop talking about it, but yeah. So that was a completely different topic. Luckily, JSR 308 annotations didn't catch on that much because they are, after 10 years coming to think about it, they are quite horrendous when you look at the syntax. Anyway, so that was my talk 8 years ago. Today, on a slightly different take on annotations. So let's start with a bit of history, like where annotations come from, and a brief overview of what are the use cases that annotations actually cover. So annotations have been introduced to Java in 2004, so that's 14 years ago, a long time ago. About that time, I also started doing Java professionally, so I don't really remember the time before annotations. I do remember, however, that people were very enthusiastic that something is going to replace the XML programming they were doing in large quantities. So annotations came into existence, I suppose, at least partly as an answer to the vast amounts of XML that you had to do at that time in Java EE and in Spring to do all the configuration and so on. So annotations have become the foundation of most modern programming frameworks. I guess it's safe to say that Spring is as standard when it comes to doing business applications in Java, and it's mostly annotation driven. There's also Jakarta EE. That's if you haven't seen it yet, that's the new name and the new logo of Java EE. Maybe the gray isn't the best color choice over here, but you can expect to see it a bit more probably in the future. So what are the use cases of annotations in our daily lives? So I guess the general idea behind annotations is to attach some metadata being data about data. So we want to attach the metadata to our classes, fields, methods, and so on. And there's a couple of use case classes, let's say, in which annotations are used. So the first one is to map your Java model, so your Java beans, to some external model, right? So this can be mapping your Java class to an SQL model. It might be mapping your Java class to a JSON model, XML model, and so on. So these are annotations like at entity, at JSON property, various XML annotations, and so on. The second class is expressing cross-cutting concerns. So, for example, specifying that a method should be run in a transactional context, or it should be run in a security context where there should be a user logged in, and so on and so on. So, using annotations, you are attaching some kind of interceptors to your methods. And finally, the third category is orchestrating the whole application. So here we have all of the dependency injection annotations, at inject, which is now standard in Java EE, which is used to describe how the whole application is being built together. There's also a lot of annotations in Spring Boot, for example, which drive which components of Spring Boot are enabled in your application, which Spring components are enabled, and how they are configured. So there's quite a lot of these annotations. So annotations have a lot of good things about them, which makes them well suited for these tasks. So first of all, they are quite easy to introduce, right? You don't need to do any code changes to actually add some metadata to your class or to your field, right? You can just write it down. You don't have to change the existing code. So that's definitely a nice property. Another one that is clearly visible, what is the data part and what is the metadata part, right? They have a slightly different syntax. They have the @ symbol. The IDE colors them in a different way. So it's easy to visually distinguish between data and metadata. They're also close to the referenced elements, right? So in the XML days, the metadata, the descriptions, or the definition of interceptors and so on, they were present in some XML file which was buried deep in the resources folder. Here, the annotations are directly attached to the elements which they describe, which again makes it easier to explore the code. Finally, and that's where most of the power of the annotations come from, annotations can be inspected both statically and at runtime. So static analysis of annotations isn't that popular and that common. There are annotation processors which can influence the compilation process, but not that widely used. Most often what people do is they read annotations at runtime, and there's a number of containers which actually understand these annotations and change the bytecode or change the behavior of the code in some way. So these are all good things about annotations, and probably these features of annotations have caused them to be so widely used. However, we have to keep in mind that most popular doesn't always mean the best. That while annotations are the foundation of the most popular frameworks, it doesn't mean that it's actually the best approach out there. So what I'd like to do is I would like to walk through a couple of use cases and actually check if there's maybe other approaches which are equally good or maybe better in some respect. So I prepared a beautiful drawing over here for you, which tries to illustrate an idea that annotations are maybe the local optimum in software development when we consider Java below 7. Right? So the idea here is that we have the line of perfect software, the yellow line. So you can get close to it, but you can never actually reach it. So it's like an asymptotic line. And then if we go up, we can go infinitely worse. Right? So we can only get we can get close to the perfect line, but we can go as bad as we want going up. Right? And on the other axis, we have various approaches to programming. So annotations are kind of form a local optimum, right? If we go and explore the XML line, well, that's definitely worse, right? We've tried that, so we don't want to go there. However, maybe if we go over the hill, over the next two hills, there are some other approaches which are actually better. So let's. And why am I talking about Java before 7? Well, Spring, Java EE, Juice, and so on. They are very popular frameworks, so they cannot innovate that fast. It's both a curse and a blessing. So the way we are doing programming with Spring or with Java EE is very heavily influenced with how programming was done before Java 7, right? So they're incorporating lambdas, they're incorporating all the new features of Java, but still, like, the programming model is heavily influenced as we've been doing that before. So let's take a look at annotations from another perspective, from a language design perspective. So if you think about annotations, they're really kind of an add-on language onto Java, right? So we have the regular Java with the ifs, loops, methods, classes, and so on. And on top of that, there are annotations which are kind of a language glued to Java with its own capabilities. The syntax is more or less similar. However, it's quite poor comparing to Java, right? An annotation can only have, properties which can be ints, strings, arrays, class references, and other annotations, and that's it, right? So comparing to the regular Java, it's quite a poor language. And it lives like in a parallel it lives in a parallel universe, so you can't really mix those two languages, right? So you cannot use an annotation in a for loop or something like that. So annotations form kind of an embedded min language inside of Java. And as I said, while it is possible to analyze annotations at compile time, people usually do it at runtime. So we have the Mannie language, which is interpreted at runtime. So what is it interpreted by then? And that's where the containers that we love so much and hate often as well come in. So the containers here are the annotation interpreters, right? So they understand the language of annotations, and they form kind of the runtime for that dynamic language. Why am I saying that annotations are dynamic? There is some basic type checking in annotations, but it's mostly syntax. But there's completely no type checking when it comes to the context in which annotations are used. You can use any annotations anywhere you want. So we have the annotations, which are the Mannie language. We have the containers, which are the interpreters. And finally, what we end up doing as programmers, we end up programming the containers using annotations, right? So once you look at annotations from that perspective, you might start to wonder, why are we using this crippled language of annotations that much, right? It's such a basic language, and it's not really that type safe. So maybe there's something better out there. So yeah, so let's, as I said, let's explore some use cases. So so let's see what annotations have become and what kind of patterns or behaviors do they encourage. Okay, so let's start with something simple. I think the first kind of pattern that annotations have developed in us as programmers is a fear of the new keyword, right? So for some reason, we think that it is a good idea not to use new as much as possible and to delegate the hard task of creating new instances to our containers. And here I'm, of course, talking about dependency injection and dependency injection containers. So the new keyword is like the basic construct in object-oriented programming. However, for some reason, we are trying to avoid it as much as possible. And we are handing over that control to the containers. So let's take a look at a simple example. Is it blurred? It's in light. Okay. So yeah. So here I'll be using Spring as an example, just because it's the most popular framework out there. It could be Java EE. It could be Juice as well. So don't attach too much meaning to the fact that it's Spring as the code examples here. So the code example is quite irregular. It's taken from the Pet Clinic project. It's a very, very simple demonstration of how you can actually use annotations to wire your application together. So we have some add component annotations. We have an add controller annotation, right, which specifies which are the classes that Spring should manage. And we also have the auto-wired annotations, which specify where the injection should happen, right? And when the container starts up, it starts interpreting these annotations, right? We don't have any additional checks at compile time. Everything will actually happen at runtime. So we have the container. It starts up. It starts checking these annotations, and then it will do the injection, right? And if there's a dependency missing, or if there's a dependency that has multiple implementations, we will get an exception again at runtime. So what is the alternative here? Well, the alternative would be to just use Java, right? And that's how people have been writing code in the Stone Age. So what people have been doing is that you just delete all the annotations, okay? And what you do, then you have the main method somewhere at the end of your programming path, and you actually create the new instances by hand, okay? And you pass all the dependencies over there and so on. Oh, the lights are dimming. That's nice. Okay, thank you, whoever did that. So yeah. And we immediately gain one thing, which is additional type safety, right? So when we try to compile that code, we will immediately get feedback if there's a dependency missing, right? Or if there are multiple dependencies, well, we can just choose the right one. So immediately we get increased type safety. We also can keep a lot of the features coming in the containers. For example, scoping, right? If we want to have an instance that has a singleton scope, well, we just create a single instance of that object, right? As simple as that. If we want to create an instance for each usage of a dependency, well, instead of a field, well, here I'm using the Java 10, by the way, Java 10 var construct, which makes the code a bit nicer. So if we want to have a new instance for each usage, we just create a method which will create a new instance for each usage, and so on. So it's as simple as that. So just using Java, we can really get a lot of the benefits on the containers, keeping the control of the code. So we don't give the control to any container. We have full control, right? If we want to create an instance in some fancy way, we don't need to create a factory, producer, or whatever. We can just create it any way we want it to. And that's something I call manual dependency injection. So at some point, of course, if you have a non-trivial project, the main method will get large, right? So here's the good programming practices still apply. So we will have to split the object graph creation into smaller pieces. So we can do it in several ways. One idea is to use packages. Maybe you have seen there's a very good presentation by Jakub Nabrdalik on how to properly use the package scope and packages in Java. The idea is that you basically use a package as a module where you put a single functionality. So maybe as part of a package, you can also have a class which creates the partial object graph for the classes contained in that package, right? And then we could compose those partial object graphs into bigger graphs and so on and so on, right? Using regular, again, simply using Java and using regular Java composition. And I also did a talk on a similar subject, how you can do manual dependency injection in Scala, but it all carries over nicely to Java as well. There's of course some downsides. We do have to write a bit more code, right? We do have to write the wiring code manually. However, it's quite simple code to write. It's checked by the compiler, so we do get some help, and it also brings some convenience to the reader of the code, right? We get some less convenience at the writer of the code, but the reader of the code actually gets some convenience because he can quite easily check how the instances are created, where the instances are created, and so on. So a related fear that we have developed because of annotations is a fear of the main method. So in the same way as we avoid using the new keyword, we avoid writing the new method. And the main is something that really should be quite important, and at least for me, it's like the first place where I would look when joining a new project to see what's happening in there. So that was it for the lights. So the main method. So at least for me, that's where you would look if you would want to understand what's the startup sequence. Okay. So apparently, if the camera wants to see me, the lights have to be on, and I guess the camera is important. So, but I hope you can see that anyway. So the main method is where at least I would expect the startup sequence of the code to be. Right? And the startup sequence is something very important. It should specify how the code and what are the services used by the code and how are they created. Right? For example, if we have a discovery service in which we want to register, and if we have an HTTP interface which we want to expose, right? It really matters in which order these two are started, right? We probably want to first start the HTTP service to bind to the interface and so on, and only then register in the discovery service, not the other way around, right? So it would be nice to have a place where these steps are explicitly stated, that first we bind and then we register in the discovery service. And again, there are mechanisms in Spring and Java EE for specifying what happens on startup using event listeners and so on, but they are more like workarounds around the problem and not proper solutions. Event listeners have their usages, but an explicit startup sequence, I guess, is a very convenient thing, especially for the reader of the code, that helps you understand what happens in your application. So again, we can imagine a very simple example of how a main method could look like, right? So first, we would have the code that's used to create the object graph, so all the new invocations. Then we create our services, and then we explicitly state what kind of services we use. So we bind to HTTP, we register in the discovery service, right? Again, if that method gets big, we would probably have to divide it into smaller pieces, but we don't really need any kind of framework or container to do that. We can just use Java. Java is quite an expressive language, so you can do a lot of things in Java, especially with the new additions like lambdas, local type inference, and so on. So the underlying mechanism here behind dependency injection and behind avoiding being able to avoid using main method is class path scanning, right? Class path scanning is a very tempting mechanism because it works in a very magical way, right? You just put something on the class path and it automatically works, right? The container automatically picks up an integration with Mongo or with SQL or whatever. It automatically picks your new entities and so on. So again, it is quite convenient if you are bootstrapping a new project. However, if you are trying to explore the project, if you are trying to understand what's happening in the project, well, this might actually be harder for the reader, right? Because some things just happen to work because a jar is on the class path, but there's nowhere in code where you can see that a particular service is being started. Or maybe there are some entities that are mapped to the database, but again, these entities aren't listed anywhere in the main method or in some reachable place from the main method, right? So I think once you see class path scanning, it is a signal that maybe you should look for some other solutions which actually allow you to express all of these things in code so that the reader of the code can actually understand what's happening in there. So what we are doing is quite often we are trading certainty and control of our code, right? We probably want to be in control over what happens both on startup and at later stages of our projects. So we are trading that for fast and convenient bootstrap, right? So what the frameworks give you is a way to really create a new service from scratch quite quickly. However, they take over the task of creating the object graph, of providing startup, and so on and so on. So again, it's very convenient for the writer, but not necessarily so convenient for the reader. And I think a very important underlying trait of your code, which you should keep in mind, is keeping the code explorable, right? So we all know that it should be easier, well, that the convenience of the reader should be the priority over the convenience of the writer. And explorability is just one aspect of the readability, right? So I think that the go-to definition that's present in most of our IDEs is one of the best methods to actually learn both about new projects and about new libraries, right? The great thing about open source is that you can download all the sources of the libraries. So then if you don't understand how a library works, you can just go to you can jump to the definition of the method or the class or whatever, and you can just read the source code, right? So I'm not saying that you should necessarily read the whole source code of all the libraries and frameworks you are using, but just having the possibility, just in case you don't understand something, to go there and read the code, that's really helpful, right? The same applies to our projects. Being able to navigate to code is very helpful if you want to understand what the project is doing, right? And having, for example, an explicit main method with the startup sequence, you can navigate to the places where the HTTP interface is bound, where the entities are exposed, and so on and so on. So imagine, for example, if you go the annotation way, right? You have an entity annotated with @entity, right? So how would you find code in JPA, Hibernate, or whatever, which actually handles that annotation, which actually maps the entity to the database table, right? Well, look, going to the definition of entity wouldn't give you anything, right? And there is no place in code where we actually expose the entity. So there's no place from which we could actually navigate to the place where the entity is actually mapped, right? Because it all happens automatically due to the class path scanning. So I think explorability is a very important trait of your code to keep in mind when trying to write nice maintainable code. Okay, so that was mostly about annotations which control how you structure your application. Now a bit about metadata mapping annotations. So these annotations allow you to map, as I said, your Java model to some external model, such as JPA annotations, @entity, JSON annotations, but also annotations for exposing HTTP endpoints. So anything that maps your Java model to some external model which you want to expose, map to, and so on and so on. So the basic idea here is that we want to somehow describe our classes methods, attach some additional information, which is then consumed by the frameworks. So as an example, we will take a Jacques mapping. Hopefully you can see a bit of that. So we'll take a fairly standard Jacques mapping. There are some annotations like @path, @get, @produces. So I guess it's quite obvious what this actually should do, right? So this code should expose an endpoint on /hello/user, which should be accessible on the method get, and so on. So again, there are some good and bad things about that mapping. So let's start with the good ones. Okay. So first of all, as I said also in the beginning, the metadata is quite clearly separated from the business logic, right? You can see where the business logic is. The business logic here is quite simple, but it's clearly separated from the annotations, and these two worlds don't get mixed. This also means that we can test the business logic without having to test to run an HTTP server, right? So everything is nice and testable. That's definitely a property that we want to have. Finally, it's quite easy to understand the intent of the author, right? The author clearly wanted to expose an HTTP endpoint, and this is clearly visible from the annotations. And finally, we get some bonus things, like we are able, for example, to automatically generate API docs, Swagger docs, by analyzing the classes and analyzing the classes and generating the docs basing on that. So these are the good things. Of course, as the presentation is about rethinking annotations, the bad list has to be a bit longer. So what could be wrong with that code? So first of all, is that the right combination of annotations that we have used, right? So that's something that the container really has to verify on startup, right? We have used this language of annotations, and now when we pass it to the container, it will interpret them, and it will interpret them at startup, and it will tell you if something is wrong or not, most probably. However, at compilation time, we have no way of verifying that actually these annotations are correct, right? We could have used @entity there as well, which makes completely no sense, but nothing would stop us from that, right? So that's one thing. The second thing is that we don't really know where that endpoint is exposed. There is no place in our code where we say, now expose these endpoints, right? This all happens automatically somewhere, and it's probably quite hard to actually find the place where the endpoints are exposed. And that also brings the third point, which is how would you approach even trying to find all the endpoints that are exposed by your application, right? They can be in some jar that is a dependency, or you can try to look for usages of at path maybe, or something like that. But again, it can be quite brittle. As for testing, we have tested the business logic, but have we tested that this combination of annotations is actually correct, right? So we have this large stack of annotations, but are they correct? Are we testing the annotations as well? Well, they are part of the code, right? So we should test them in some way. So are we doing that? I suppose quite often we don't. And finally, we have some stringly typed parameter references, right? So in annotations have a tendency, because they're quite a poor language, so people put sometimes whole expressions or whole SQL queries inside the strings, inside the annotations. So we have like a mini language on top of Java, and inside that we have yet another expression language, right? And there, well, it's a string, so it can be anything, right? It's totally not verified until it's being actually used. So there are some things that we could probably improve. So let's now look at an alternative. So the API here is completely imaginative, so it doesn't exist, most probably. It just serves as an example. So what if we tried to represent the metadata about the endpoint as a Java value, right? So here you probably can see a recurring theme of trying to just use Java instead of using containers, frameworks, annotations, and so on. So as I said, Java is quite a powerful language, and you can do quite a lot of it with it, especially now that since Java 8 and now in Java 10, we have all these new syntactical possibilities which make the code actually more readable than before. So yeah, so what if we tried to represent the endpoint as a Java value, right? So what we would do is we would probably, we remove all the annotations from our business logic. So we have our business logic intact. It's still testable, right? But now we define the metadata in a separate class, maybe like in the same source file below this, or maybe it's another source file in the same package, something like that. So what we do is we would probably have some way of defining the endpoint with a fluent interface, right? So we have the with path method, then we specify the method that the endpoint should respond to as get, we specify the content type, and so on, right? So what we do here is we use a Fluent API to create a description of our endpoint that we want to expose as a Java value, right? Now, once we have that Java value, well, it's just a value, right? It's hanging in there. It doesn't do anything by itself. So we will still have to do something with it. But we still maintain quite a lot of the good things that we had with annotations, right? We can test the business logic. We can probably generate Swagger docs as before. We just need, again, a bit more code, a bit more work to actually gather all the endpoints which are being all the endpoints described as Java values and pass them to the Swagger generator, but it's still doable. But we also gain some things, right? For example, we can programmatically define endpoints, which we'll see in a minute. So what we really, the additional step that we need to do is once we have these endpoints described as pure Java values, right? We have to gather them at some point, and probably like in the main method, which we are now using, we will gather all the endpoints from all our classes into a single collection, and then we will start the HTTP server passing that collection of endpoints, right? And if you are looking at that code, I guess it's crystal clear what's happening here and in what order and so on, right? So you don't have to know a lot about some container framework and so on to understand what's happening here, right? You can navigate to each part of the definition. You can navigate to where the endpoint is exposed, to where the endpoint is defined, and so on. So, as I was saying, with when you start defining metadata as Java values, you actually get a lot of additional possibilities which you didn't have before, because you have all of Java at your disposal, right? Now the metadata is first-class values, which are just ordinary Java values, just as everything else, right? So we now can have a single language, both for the code and for the metadata. So what we get is we get loops, we get conditionals, we get helper methods, and with that we can define our metadata. So imagine that, for example, I guess it's quite a common thing when you're doing JPA mappings, right? So you have an entity and you have an entity which has a generated value as the ID, right? So you have this big stack of annotations copied over all over the place, right? So you have the ID, because let's say the ID. Then you specify that it's a generated value using a table generator, and then you specify the table generator specifics, right? And you would have, because annotations are static and they are quite a limited language, what you have to do is you have to copy that over to each entity. What you could do instead is with the metadata as a value approach, you can create all the mappings as values, loop over them using a for loop, and add these table generators information to them using a single statement, right? So instead of copy pasting code, you can just loop in the side of Java and generate that automatically. So if that's not enough, there's actually a website created by enthusiasts of annotations, enthusiasts like in quotes. It's called Annotation Mannie, so you can there are some good resources over there as well. And there's also a presentation by Jarek Ratajski on a similar subject. One thing that I especially like there is when he tries to define an annotation that would put a method in a transactional context, but the transaction should be retried, I don't know, 3 times, let's say, if it fails, right? So it's like a combination trying to compose the at retry and at transaction annotations, and with annotations that's not really possible. If we use Java, then it's a different case. Yes, Jarek? Okay, so I'm not sure which way does this go, but yeah. Okay, so, well, you may wonder, I was showing you some imaginative API. So you may wonder if is it just my fantasy, or are people actually doing that, right? And now I'd like just to show you 3 short examples of libraries which actually use that approach to coding. The first one is Spark Java, which is a library for defining API endpoints. And they do quite a similar thing as we did in our example. So with Spark Java, there's a set of methods with which you build description of endpoints that you want to expose. And you can see that it quite heavily uses lambdas and the Java 8 features. Another library is Jacques, which is actually quite an old library. It's a library for talking to SQL databases. And it's quite often a very good alternative to JPA. It doesn't use any annotations. What it does is you just use Java to specify how you specify the queries that you want to run and how you want the query results to map back to Java classes. It's quite a well-established library, so actually quite a lot of people use it. And finally, even Spring. And Spring 5 contains something that's called Functional Web Framework. So it's part of the movement to make Spring reactive, because everything is reactive right now. So it's like an alternative way for defining for defining web endpoints. And here you can see that they are taking a very similar approach to what we've been doing as well. So on the left, you can see that you are using some methods to create description of endpoints. And then this description of endpoints, which contain the path, the method, and the logic to run when that endpoint is invoked. Well, that is passed. Here at the bottom, you can see that there's an HTTP handler, adapter, because the name has to be complicated enough. And then you pass in all those handlers to Spring as well, right? So I guess the fact that Spring is actually moving in that direction as well kind of validates the whole idea. And that's also because of the new possibilities that Java 8 gave us, right? This code would be really ugly before Java 8 if you didn't have lambdas. So that's probably also why people were actually using annotations. But Java is not all. There are also other languages out there which have various additional capabilities. So, for example, in Scala we have macros and implicits, which make it much easier to work with metadata and to generate some metadata mappings at compile time and have them verified at compile time. In Ceylon, for example, we have a fully type-safe meta model, so they go a bit of the other way around. So they make it easier to work with compile time checking of annotations. Okay, so a bit of a summary. So about Spring, like I wouldn't want you to see that as an anti-Spring presentation. I was just using Spring because it's so popular. So Spring definitely has great docs integrations. It's also probably quite good for business applications. It's quite learnable because of the docs and of the integrations, right? However, what you have to keep in mind is as you are learning Spring, what you're actually doing is you are learning the language defined by Spring through the annotations, right? And you are learning how to program the Spring virtual machine, kind of. You are learning how to program the Spring container using the Spring annotations, right? So it is something you can do. You can also program in Ruby and other dynamic languages, of course. So it is something that you could do. However, I think there's a lot of missed opportunities here when it comes to static typing and static type checking, right? So, and Spring 5 kind of also goes into that direction. So I think we can maybe improve some of the things that Spring actually does. So just to reiterate on the main things here. So when we start looking at annotations from a different angle, annotations form this mini language which is glued onto Java. Okay, something changed. Did it just start working? Okay, so I hope you heard me before as well. Okay, anyway. So annotations are form this mini language that's glued on top of Java, and then which is interpreted by containers. So the language is not really type safe. There's no context checking or anything like that. So the alternative here is that we could use a proper language such as Java to replace some of these usages, or because there's really a lot of possibilities on the JVM, it's quite easy to use another language. Maybe we could also try using other languages and see how they solve these problems, such as Scala, Kotlin, Ceylon, and others. If we decide to use Java, there's no reason to fear using the new keyword or the main method. They're quite important constructs. So the main method is like the main entry point to your code, and it should be the natural way where you would go to understand what your code does, what your service does, what kind of components it uses, and so on. And writing a bit more code is probably okay. So like we're always looking for ways to actually minimize the amount of code that we write. However, writing a bit more code, if it is at the expense, if it increases explorability of your code, if it increases readability of your code, that's fine as well, right? So the ultimate goal shouldn't be minimizing the number of lines, because then we would end up doing Perl. Instead, we should try to use, some. It stopped working again. We should probably use some balance between the amount of code we write and how explorable and how readable it is, right? And finally, when we create, when we express metadata, when we express the descriptions of the mappings that we want to have in our code as Java values, we really get a lot of additional possibilities. Okay, so if you are interested in that or similar subjects, there are also articles on our blog.softwaremill.com. There are both articles about annotations and how to not fear the main method, and many other interesting things. You can also try to find all the hidden programming references inside our blog logo. And that's all I had. You can. I'll be here until Friday, so you can. If you would have any questions, feel free to ask me. You can reach me on Twitter, email, and so on. So thank you very much.